All right, here are the counts in thousands of earned degrees in the United States in a recent year, classified by level and by the sex of the degree recipient. So we've got males and females, and we've got the types of degrees that they've earned. If you choose a degree recipient at random, what is the probability that the person you choose is a woman? So 856 out of 1626. So what is that, about half? That's 0.526. What is the probability the random chosen person is a man? Well, if that's 52.6%, then this must be what, 0.474? So we can crunch that out. 770 out of 1626 is 0.4735, so 0.474. What is the conditional probability that you choose a woman, given that the person chosen received a professional degree? All right, so here's the professional degrees. So given that we're saying, what's the probability of female, given that you're in the professional degree category? So we're only looking at the professional degrees. What's the probability that we pick a female? Well, there's 30 out of 74. So 30 out of 74 is 40.5%. What is the conditional probability that the person chosen received a bachelor's degree, given that he is a man? So that means now we're looking at the males. What's the probability that the person is a bachelor's degree recipient? Well, there's 529 out of 770. So we're saying, what's the probability of a male, given that you have a bachelor's degree? Oh, did I write that right? What is the conditional probability the person chosen is? Oh, I wrote that backwards, right? So we're saying, what's the probability that the person received a bachelor's degree, given that he's a man? I wrote this as, what's the probability of a man given bachelor's degree? So that's backwards. So we're going to say, what's the probability that we get a bachelor's degree, given that the person is male? So I'm only looking at the males. So what do we have? 529 out of 770. And what is that? And I get 0.687. Are the events choose a woman and choose a professional degree recipient independent? Well, if they are, then the probability of picking a female is going to be the same as probability of female given professional degree, right? So the professional degree shouldn't tell us anything about the female or the gender of the recipient, but in fact it does, right? Because up here we said, well, if of the professional degree recipients, only 40% are female, but 52.6% of the entire population is female. So this is not true. Therefore, they are dependent. Remember, that would have to be true for them to be independent. Use the multiplication rule to find the probability of choosing a male bachelor's degree recipient. So we're saying, what's the probability of male and bachelor's degree? So that's going to be the probability of male times the probability of bachelor's degree, given that we've chosen a male. So what do we have? Probability of male, 770 out of 626, 1626, times bachelor's degree, given that we're male. So I'm only looking at the males now. So bachelor's degree, given that they're male, is 529 out of 770. Those cancel, and I get 529 out of 1626. So 529 out of 1626 is 32.5%. Confirm your answer to 6 by finding the probability of choosing a male bachelor's degree recipient directly from the table. All right, so who are the male bachelor's degree recipients? These guys, out of the table, 1626, right? So male and bachelor's, it's this out of the total, so 529 out of 1626. Same thing.